Hello students, this is Dr. Yogita Datar, subject teacher of Engineering Mathematics 3 from Sri Siddheshwar Women's College of Engineering, Solapur. In the last video, I have told you that engineering mathematics is a very good subject or a very good way to score maximum marks in engineering course. It is nothing but a shortcut to be a ranker in the university in your engineering course. But there is a condition. The condition is that you should have the proper and perfect knowledge of or the sufficient knowledge of the prerequisites for this engineering mathematics course. So, what are the prerequisites? We will see now. First of all, the derivative or differentiation rules. You have studied derivative in 12th standard, and in case of diploma students, you have studied it in this concept in first or second semester of your diploma course. So, you should know all these rules. The rules of differentiation, addition rule or sum rule, difference rule, product rule, quotient rule and chain rule. And obviously, along with the derivative, you should have the knowledge of integration formulae. How to find integration of a given function, which methods to be used to find the integration of the given functions, you should know it very well. Here in this table, the derivative and integration of the related functions are given. So, everyone should have sufficient knowledge of application of this derivative and integration formulae, rules and methods to solve the examples. Along with this derivative and integration concepts and formulae, you should know the expansion and factorization formulae. Actually, we have studied all these formulae, all these concepts in 7th, 8th, 9th standard. So, everyone should know all these formulae perfectly. So, what are these formulae? The square expansion of a plus b, the square expansion of a minus b, cubic expansion of a plus b, cubic expansion of a minus b. Along with this expansion formulae, you should know the factorization formulae, very famous. First one, a square minus b square. Then along with this one, a cube minus b cube and a cube plus b cube. After this one, what we require is laws of indices and laws of logarithm. And we have studied these two concepts in 8th and 9th standard. So everyone should be able to apply laws of indices and laws of logarithm. So these are the laws of indices: product, quotient, power, zero exponent and negative exponent. These are the laws of indices. And related with the product law of indices, there is addition law of logarithm. And so there is perfectly one law of logarithm associated with the law of exponents. So now we will go to the actual syllabus of Engineering Mathematics 3. The syllabus contains, or the syllabus is divided into 6 units. First one, Laplace Transform. Second one, Inverse Laplace Transform. Then next, another transform, that is Fourier Transform. After this one, Partial Differential Equations and their applications. Now the next 2 units are from Complex Variable. So functions of complex variable, which is related with differential calculus, is the 5th unit, and functions of complex variable, which is related with the integral calculus, is the last unit. So our syllabus of M3 is divided into these 6 units. When you actually go through the content of these 6 units, you will know that the derivative and integration formulae are must to solve the examples from all these 6 units. Now we will go to the first unit, that is Laplace Transform. So why you should study Laplace Transform? Because the Laplace transform is having n number of applications in engineering, specifically in electronics and telecommunication engineering and electrical engineering. So some of the applications are in field of control engineering, in the field of communication, in the field of signal analysis and design. The next one, application of computer engineering, that is system analysis. Now we come across many differential equations while studying different branches of engineering. So in that case, to solve the differential equations, Laplace transform is the best method. And also in the field of electrical engineering, we have to apply Laplace transform in many cases. Now we will start the actual syllabus of this unit 1, Laplace transform, from our next lecture. So by the way, I wish to give you one mathematics trick. In standard 7 and standard 10, you have come across with the very famous theorem from the geometry, that is Pythagoras Theorem. So all of you know that Pythagoras Theorem deals with the or associated with the right angle triangle. And you have solved the examples based on this theorem many times and you have scored also. Now suppose you are given one example where the sides of the triangles are 3 units, 4 units and 5 units. And if you are asked to check whether the given triangle is a right angle triangle or not, we apply Pythagoras theorem. And we can prove that 3 square plus 4 square equal to 5 square. And hence by the inverse of Pythagoras theorem, we can say that the given triangle is a right angle triangle. The same is the case with the triangle with the sides 7, 24 and 25 units. So what are these two triplets? These two triplets are nothing but the Pythagorean triads. So you can easily check whether the given triangle with the 3 side lengths is a right angle triangle or not using Pythagoras theorem. But how to form a new triad? How to form a new Pythagorean triad? So it is very simple. Take any odd number greater than or equal to 3. Suppose 9. Take its square, that is 9 square equal to 81. Now make two parts of 81 such that the difference is 1. Or we can say divide 81 into two parts such that the difference between these two parts is 1. So surely the two parts of 81 are 41 and 40, as the difference between them is 1. So now we are having 3 numbers with us. The original number, odd number which we have considered, that is 9, and these two parts 40 and 41. So 9, 40 and 41 will form a Pythagorean triad. You can check. So what should be a Pythagorean triad? The square of the smaller numbers, their addition should be equal to the square of the larger number. So now in our case, in this example, square of 9 plus square of 40 equal to square of 41. So in this way you can form a new triad. So by the way, we will stop here. Have a good day. In the next lecture, we will start with the actual syllabus of Engineering Mathematics 3. Good day.